Alright, so we're dealing with more complex linear transformations, and by that we mean we're going to make the complex simpler by using sequences of simpler transformations. So we're doing linear transformations with matrices, but we're looking at how can we put a sequence of simpler transformations in place to do this. So it makes the complex much more simple. We're going to do two examples or two case studies of this, which I expect you to be across. First one is rotation about point AB, and i.e. that's not the origin. In the past we've done some work on the origin rotations as the center of rotation, but we're looking at what if it's not the origin. And the second and final one was to do a reflection, you like my shorthand, reflection in y equals x tan theta, or tan theta times x tan theta plus c, i.e. the line does not, that line does not go through the origin. Okay, so the first one therefore will be an example to do with the first context I just mentioned, and we are going to determine the transformation that rotates the plane 90 degrees anti-clockwise about 1, 1. 1, 1 is not the origin. So you'll find this has three steps. Step 1 is that we have to translate the plane, so translate, slide, reposition, translate the plane so that the center of rotation such that center of rotation is the origin. This is what we do first. Step 2, we do the rotation by theta, anti-clockwise, and it's 90 in this case. Step 3, we translate the plane back to 1, 1. The given point. Now the matrices that are applying to this, if we're going to call this point that's not the origin A comma B, we basically need to come up with a matrix that performs that. That matrix is x minus A, y minus B, arranged in a column matrix as such. So the matrix for step 2 is cos theta sine theta, negative sine theta, cos theta. That's rotating the plane by theta degrees anti-clockwise. Sorry, my matrices are a little bit out of line there. Apologies there. Okay, that's from our previous work, and that is on your formula sheet, your QCAA formula sheet. And the result then has A and B added to return it back to 1, 1. So in this case, A and B are the given values. So let's have a closer look at the flow, how it works. So we have an initial point x, y. Now, step 1 kicks in. So we have x minus 1 in this case, y minus 1, and that will translate according to step 1 above. The next stage then, theta is equal to 90 degrees. So in the step 2 matrix there, we need to find those. Hopefully you're good with your exact values. Okay, so cos of 90 is 0, sine of 90 is 1, that will be -1, and that will be 0. That operates on the previous matrix that we just had there, x minus 1, y minus 1. Remember our previous work, the order is the opposite to the way the matrices are arranged, okay? So remember that from our previous work. So that together will give you your rotation 90 degrees anti-clockwise, okay? So to translate it back, we then have the previous result and we have to add A and B on, which is, sorry, 1 and 1. Don't need to write A and B anymore, we have 1 and 1. Let me tidy that up for you, like so. And that will translate it back, and we've completed it. Once we've worked this out, the actual calculations are easy. So that was the hardest part just there, figuring out the sequence. So let's write the calculation out properly. So the result, the image, the finished transformation, okay, basically this here, we're bringing it over and actually doing it. Okay, so, whoops, that's not a proper matrix, Mr. Herbert. That's better. Okay, so I'm going to do the multiplication bit first. So we have 0 times x minus 1 plus -1 times y minus 1, which is 1 minus y. Then we have 1 times x minus 1 plus 0 times y minus 1. Now let's add the 1 onto that. So adding the corresponding elements, and one way you could write it is that. There we go. That is the overall transformation. That essentially is the answer. Now, if you're asked to test your answer, you just find a test point. I've just chosen 0, 1, and does it work? Well, let's apply the matrix to 0, 1. And it works because you can see diagrammatically that it ends up, if you rotate it, about the center 1, 1, which is there, and you go anti-clockwise, which is like that. It by 90 degrees it ends up there. See, it travels in an arc for 90 degrees. Okay, and anti-clockwise you get 1, 0, and there's the calculation, and I just sub that in. Remember, that's x, that's y, and I sub that in there, and it works. Okay, so the second type, find the transformation that reflects the plane in the line y equals -x plus 1. Once we've done that, then we test with the test point 1, 1. Okay, step 1, we are not going through the origin, so this here is translated vertically by 1 because the y-intercept is 1. So what we need to do is use this matrix here, where C is the y-intercept, and we need to apply that to translate the line down. Thus, this line will then pass through the origin. From your previous work, you'll know to reflect the plane in the line y equals x tan theta. You apply the cos 2 theta, sin 2 theta, sin 2 theta, negative cos 2 theta matrix. Step 3, the final step, is to translate it back. considering the y-intercept, we add in that matrix there where c is the y-intercept. It's 1 in this case. Just remember, these matrices are on your formula sheet. So let's put this together like we did with the other example. We've got our result x dash y dash. Now remember the order, so because of these two here, they have to be multiplied. Okay, so this one goes first, and then we apply this one here where y equals 1. So if we take c off, it's y take 1, and then we have to add that back on. Alright, because the intercept's 1 there. Tricky thing, I've just put this down the side here. You need to realize, just do a little sketch of the graph perhaps. That's the line y equals negative x plus 1. Okay, and be careful, because if you just look at tan theta, you need to remember that it's in the positive x direction. So that would make this little angle here I've written in green. Okay, and so we've got 135 degrees. If you think about that, that'll be it'd be 45 plus 90, and you might need to pause the video and think about that a bit. You get 135, so 2 theta would be 270, so cos 270 is 0, sine 270 is negative 1. Think about your unit circle. If you're having trouble calculating these, you may need to pause the video. Negative cos of 2 theta is 0. Likewise, we put on the next matrix there. That's why I wrote that matrix down in terms of cos and sine first, because that to some people might be a bit of a step depending on how you are in your Cartesian planes and your trig. And we have 0 times x, negative 1 times y minus 1, so that's negative y plus 1, and we've got negative x plus 0, so that just stays as negative x. Now we add on the 0, 1, and we've got a result here. We've got negative y plus 1, and we have negative x plus 1. Now the instruction originally said test with point 1,1. Does this reflect it in the plane in the line y equals negative x plus 1? Well, there's our line y equals negative x plus 1 there in red. And let's follow that. So if we have 1, 1, and we apply this matrix here, we have x is 1 and y is 1. So put y first, which is negative 1 plus 1. And we have negative 1 plus 1 there. So we have 0, 0. The origin, interesting. And look, if we have a look at the diagram, this does reflect every point in the plane about the line y equals negative x plus 1. You can see it there. It's a reflection. It's like a mirror image. This point is of this original point. Happy times.